Chapter 12, Areas related to circle. Areas related to circles. Chapter 12. What are the different concepts you'll see in this? Because we have to know in a circle what's an arc, what's a chord, what's a diameter, what's a sector, what's a segment. All these areas we'll be finding out. So what are those areas, how to find out the area of those related to circles, we'll just see. So first we'll draw a circle of any radius. Now in this circle, this is the center O. This is called the radius. Then I'll name each part so that we can know what is it. I will write down the different definitions for this. So from this we'll see what is sector of an arc, what's a quadrant. Okay, first we'll write down what is the basic definition. What's a circle? Circle is nothing but it is the locus of a point in the plane which moves such that its distance from the fixed point remains constant. So now the fixed point is nothing but O over here. Okay. So now going into what is O and what is R, we'll just see, and what is D. The fixed point O is called the center, and the constant distance R is called the radius of the circle. And here we are having OP is equal to OA is equal to OB is equal to R. That is the radius of the circle. And OC is nothing but equal to diameter of the circle, which is equal to D, which is equal to 2R, twice the radius. Next point. We're just writing all of them in points. So first I wrote down what is the definition, then what is a fixed point O. Now we'll see what is the perimeter of a circle. Is generally known as its circumference. Now perimeter, usually when we are calculating for square, for rectangle, we add up all the sides. Here we completely measure what is the length of that circle. You can take a thread and do, or you have a formula for that, that is equal to circumference is equal to 2 pi r, where r is the radius. Okay, now what is the sector of a circle? We'll see. Sector of a circle. Now it is the region which is enclosed by two radii and arc of a circle. Now you're having that AB is nothing but it is called as, if I take it in this is the arc of the circle. This is called as the sector of the circle, which I have drawn in green color. This is called as the sector of the circle, all this part. So it is nothing but, if you name even this here, it will become ACB is an arc of the circle, and OACBO is the sector of the circle with center O. Now here we have what is a minor sector and again major sector. So minor sector is this part where you have this arc, and the remaining all which is left out in the circle is nothing but the major sector. So we'll just write down over here what is the a region enclosed by two radii and arc of a circle. In the given figure, OACBO is a sector of the circle with center O. So what's a sector of a circle? It is a region enclosed by two radii and arc of a circle, OACB. OACBO is the sector of the circle with center O. Now here you are having 1/4 of the circle is called as 1/4 of a circle is called a quadrant. The central angle of a quadrant is 90 degrees. Now from the figure we have here, if this is the figure, isn't it, AB is called the arc, and then BA is called the one more arc. So AB is the minor arc and BA is called as the major arc. You can see over here, this from here to here, this is minor, and B to A, this is called as the major. So from the figure you are having that AB is called the minor arc and BA is called the major arc. Then we have what is called as segment of a circle. So what is segment of a circle? We'll see by drawing a figure again. So we're drawing a figure. Now here wherever I am putting the dots over here, this is the major segment because it is occupying the major part of the circle, and this down of AB where I put the lines, that is called as the minor segment. So this is called as the minor segment This is called as the major segment. So segment of a circle is nothing but it is a figure enclosed by a chord. You know that AB is a chord and an arc of a circle. So here arc of a circle is nothing but ACB and AB is a chord. So ACB plus AB will give you your minor segment over here, and then here AB with BDA will give you the major segment, that is the dotted part of the circle. So here in the figure, the chord AB divides the area enclosed by a circle in two segments. The segment ACB is called minor segment, whereas segment ADB is called major segment. Now the center of the circle, where does it lie? The center of the circle, lies in the major segment. So now you're having different formulae for this. What are those different formulae which will be using in areas related to circle? So the first formula which we have is circumference of a circle with radius r is given by 2 pi r or pi d, where d is equal to 2r, where d is nothing but the diameter, and diameter is equal to twice the radius. Now, second formula which we have is area of a circle, which is equal to pi r square. Then third one, area of a semicircle, which is equal to pi r square by 2. Then the fourth one, perimeter of a semicircle, which is equal to pi r plus 2r. Then we have what is area of a quadrant of a circle. Area of a quadrant of a circle is equal to pi r square by 4. Next formula which we are having is area of a ring, that is from the below figure I am doing that. So radius of the bigger circle is capital R, radius of the smaller circle is small r, center of the circle is O. Now of the ring, that is the shaded part, that is which is shaded in blue color, is equal to nothing but pi capital R square minus pi small r square, which can be written as equal to pi into r square minus small r square, which is equal to pi into capital R plus r into capital R minus r. This will be more easy. So these three we can be using. All three are the same. So area of a ring or shaded part is equal to this. Now next formula which we are having is length of an arc So for this also we'll draw one more figure and then we'll see how to do this. Of an arc we'll see. Let triangle ACBO, you can see from here ACBO is a sector by an arc AB with subtends an angle theta at the center. So you can see that angle which is made with the center from that arc ACB is nothing but theta. So now here when theta is equal to 180 degrees, then the length of an arc ACB will be AB is equal to half the circumference, half into circumference. We are taking a length, remember it's not area, say half into circumference, which is equal to half into 2 pi r, which is equal to pi r. So now here therefore if angle AOB is equal to theta, then the length of the arc will be, this is important, this formula will be pi r by 180 into theta, that is pi r, or you can write this as theta by 180 into pi r, which is equal to theta by 360 into 2 pi r. That is, we are multiplying by 2 in the numerator and denominator. We are going to get it as theta by 360 into 2 pi r, or this, hence the area of the sector is equal to pi r square into theta by 360 degrees. So this is the way we find out what is the area of a sector. Length of the arc is theta by 360 into 2 pi r. Whatever is theta, whether it is making an angle of 60 degrees, 40 degrees, 50 degrees, whatever it is, we put it in the place of theta. Now next, ninth one, perimeter of sector OACBO is equal to OA plus OB plus, you can see here, OA plus OB plus the length of the arc ACB. So how do we write this? We write it as OA plus OB plus length of arc ACB. So now here what is length of OA? It is nothing but the radius. OB is the radius, and length of the arc, just now we found out what is it equal to, 2 pi r into theta by 360. So which is equal to 2r plus 2 pi r theta by 360. So this is the formula for perimeter of a sector. Next, what is the area of the minor segment? We'll see. Area of the minor segment. The minor segment, this part. So here also it's enclosed between two radius. So those are nothing but the minor segment. So area of the minor segment ACBA is equal to area of the sector OACBO minus. So now here you can see what is the sector. This whole part is the sector, that is which I am drawing here. This line, this whole thing, the green line, green part is nothing but the sector, that is OACBO, the white part. The outline of the white part is nothing but the sector, and the segment is ACBA. Only this small part is nothing but the segment. So now how do we find out the area of the minor segment? Is area of sector OACBO minus area of triangle OAB. So now we have to find out here area of the sector plus area of OAB, then we minus both of them, we get the area of the minor segment. So now what are those? We'll just put here. So area of the segment sector is equal to nothing but pi r square theta divided by 360 minus half r square sine theta. Now here area of the triangle is nothing but half into r square into sine theta. Using trigonometric ratios you can find out what is the area of triangle OAB. Now next, what is the area of the major segment? We'll see. Area of major segment BDAB. The other part, the other than the minor segment, will become the major segment in that circle. So that is area of a circle minus area of the minor segment. Now you are having this as the area of the circle, you know that it is equal to pi r square. Now we just now wrote what is the area of the minor segment. Now if you remove that minor segment from the area of the circle, you will get what is the major segment. So now area of the minor segment, area of a circle minus area of the minor segment, which is equal to pi r square minus of pi r square theta by 360 minus half r square sine theta. Now this is the formula for area of the major segment. So we know what is the area of minor segment, area of minor segment and major segment, both are involved. Area of circle is also involved in finding out the area of the major segment. If all of them are known, then we can find out. Then you have some useful results. When two circles touch each other internally, when they touch each other externally, how do we find out? So here some important points, useful results. So you're having one circle, and if one more circle is touching it internally, how do we do that? How do we find out the radius? We'll see. There's one more circle, which is two circles. When two circles touch internally, then distance between their centers is equal to difference of their radii. That is You can see from this O dash is equal to OP minus O dash P, which is equal to capital R minus small r. This is the formula for when two circles touch each other internally. When two circles touch internally, then distance between the centers is equal to difference of the radii, that is equal to O dash is equal to OP minus O dash P, which is equal to R minus capital R minus small r. Now this is the first bit which you are having in usual results. The second one is, here again we have to draw two circles. Here the two circles touch each other externally. So when they touch each, so if you take this as P over here, this point, this is P, this is small r, and this is capital R. So now here these two circles touch each other radius. So when two circles touch externally, then distance between their centers is equal to sum of their radii, that is you have O dash is equal to OP plus PO dash, or O dash P, which is equal to capital R plus small r. Then you have some rotating wheels also. There's some formulas based on them. Formula or results you can write down. Rotating wheels will take here. Rotating wheels. When we use rotating wheels, here we have some formulas for this. Circumference of each wheel is equal to 2 pi r units. Then distance covered by a wheel in one rotation is equal to nothing but 2 pi r. It's nothing but the circumference of the circle. Then the number of rotations completed by a rotating wheel in 1 minute is equal to distance moved in 1 minute divided by the circumference. So distance moved in 1 minute divided by the circumference will give you the number of rotations completed by a rotating wheel in 1 minute. Now here clocks. For clocks, what do? We'll just see. First one, angle described by the minute hand of a clock in 60 minutes is equal to 360 degrees. Then angle described by the hour hand of a clock in 12 hours is equal to 360 degrees. So you have to remember these. These are the important concepts which you are having. Now we'll go into exercise 12.1, chapter 12, that is areas related to circle. So what is the first problem? We'll see. The radii of two circles are 19 centimeters and 9 centimeters respectively. Find the radius of the circle which has circumference equal to the sum of the circumference of two circles. So now here solution, how do we do this problem? We'll see. So let the radius of the bigger circle, how much it is? 19. Radius of the bigger circle be capital R centimeters and radii of two smaller circles be R1 and R2. Then according to the question we have that circumference radius of the bigger circle is equal to the sum of the circumference of two smaller circles, and the radii of the two circles are given to us. So here we are having 2 pi capital R is equal to 2 pi R1 plus 2 pi R2 is given. So for us here R1 is equal to 19 centimeters and R2 is equal to 9 centimeters is given to us. So therefore 2 pi capital R is equal to 2 pi into 19 plus 2 pi into 9. So therefore you are having 2 pi R capital R is equal to 2 pi into 19 plus 9. So now here you can cancel this 2 pi and 2 pi. So R is equal to nothing but 28. So hence the radius of the circle is 28 centimeters. This is the radius of the circle. Now what is the second problem? We'll see. The radii of two circles are 8 centimeters and 6 centimeters respectively. Find the radius of the circle having its area equal to the sum of the areas of two circles. So previously we were taking the circumference, now we have what is the areas. The same type of problem but we are having here with areas. So solution over here, let the radius of the required circle be capital R and radii of two given circles be R1 and R2. Then from the question we have that then pi capital R square is equal to pi R1 square plus pi R2 square. We have that the area of the bigger circle is equal to sum of the area of the two circles, given two circles. So therefore here you are having R1 is equal to 8 centimeters and R2 is equal to 6 centimeters. So now substituting in this, pi capital R square is equal to pi into 8 square plus pi into 6 square, which is equal to pi into 64 plus 36. So therefore pi capital R square is equal to pi into 100. So therefore pi is getting cancelled. R square is equal to 100, which implies that capital R is equal to 10 centimeters. So radius of the circle is nothing but 10 centimeters. Now third one. Now we are given a figure over here. So I just will draw in those colors if they are available. Black, white is also there. So the figure depicts an archery target marked with its 5 scoring areas from the center outwards as gold, red, blue, black and white. So these are all I have written over there. So the diameter of the region representing gold score is 21 centimeter and each of the other bands 10.5 centimeter wide. Find the area of each of the 5 scoring regions. So how do we do this? We'll just see. Solution. Small r is equal to radius of the region representing gold score, and which is equal to 10.5 centimeters. Now R1 is equal to radius of the region representing, we are having in R1 both gold and red also. So representing gold and red scoring areas. So which is equal to 10.5 plus 10.5, which is equal to 21 centimeter, which is equal to 2r centimeters. Then what is R2? We'll see. R2 is equal to radius of the region representing gold, red and blue scoring areas, which is equal to 21 plus 10.5 centimeters, which is equal to 31.5 centimeters, which is equal to 3 r centimeters. Then now what is R3? We'll see R3 is equal to radius of the region representing gold, red, blue and black scoring areas. So which is equal to 31.5 plus 10.5 centimeters, which is equal to 42 centimeters, which is equal to 4r centimeters. Now what is R4? We'll see. Radius of the region representing gold, red, blue, black and white scoring areas is equal to 42 plus 10.5 centimeters, which is equal to 52.5 centimeters. So now what is this equal to? 5r centimeters. Now we have to find out what are the areas for each and everything. So now what is, you can take it as area, the first gold area, gold circle area is equal to A1, which is equal to area of the region representing gold scoring area, which is equal to pi r square, which is equal to 22 by 7 into 10.5 whole square, which is equal to 22 by 7 into 10.5 into 10.5. Then you're getting it as 346.5 centimeter square. This is area of the first gold area, gold scoring area. Then A2 will take it as area of the region representing red scoring area. Only for finding out the radius we took both of them, but here area, you know what is the radius for red scoring area. So using directly that formula we can do. So it is equal to pi into 2r whole square minus pi r square, because we already calculated gold part. In this red part you are having a gold part, so you have to minus it. So which is equal to 4 pi r square minus pi r square, which is equal to 3 pi r square, which is equal to 3 into pi r square. How much did we get here? We got here pi r square is equal to 346. So we are writing directly 346.5 centimeter square, so which is equal to 1039.5 centimeter square. Now going into what is A3. A3 is equal to area of the region representing blue scoring area. So that is equal to pi r square. Here r is nothing but 3r whole square minus pi 2r whole square. You are minusing the whole of red from this, so which is equal to 9 pi r square minus 4 pi r square, which is equal to 5 pi r square, which is equal to 5 into 346.5 centimeter square, which is equal to 1732.5 centimeter square. Next, going into the fourth area, area of the region representing black scoring area, which is equal to pi into 4 pi r whole square minus pi into 3r whole square. So which is equal to 16 pi r square minus 9 pi r square, which is equal to 7 pi r square, which is equal to 7 into 346.5 centimeter square, which is equal to 2425.5 centimeter square. Next, last, we'll go into last circle, area of the region representing white scoring area. So now you have to remove the whole of black part. Till black part you are having it as 4r, the radius, and the white part is 5r. So therefore it is, area will become pi 5r whole square minus pi into 4r whole square, which is equal to 25 pi r square minus 16 pi r square, which is equal to 9 pi r square, which is equal to 9 into 346.5 centimeter square, which is equal to 3118.5 centimeter square. So this is the way we do that problem. Next, fourth one. What is the fourth one? We'll see. The wheels of a car are of diameter 80 centimeter each. How many complete revolutions does each wheel make in 10 minutes when the car is traveling at a speed of 66 kilometers per hour. So now here what is given in this question? You are given the diameter of the wheel is given, and how many revolutions does each wheel make in 10 minutes he is asking. So we will first find out distance travelled in one revolution, that is 2 pi r. Okay, so what is the speed of the car? Then distance covered by the car in 1 minute will do, and then distance covered by the car in 10 minutes will do, and then number of complete revolutions will calculate. So therefore radius of the wheel is equal to 80, because diameter is 80, so you are taking 80 by 2, which is equal to 40 centimeters. Therefore the distance travelled by the car in one revolution is equal to 2 pi r. That is nothing but the circumference. So 2 into 22 by 7 into 40, which is equal to 1760 divided by 7 centimeters. Now what is the speed of the car? Speed of the car is equal to 66 kilometers per hour. So we convert it into centimeters per minute, because you are having centimeters and minutes over here. It takes 10 minutes and 80 centimeters is the diameter. So we'll convert. So what to convert it, you know that 1000 kilometers into so you're getting it as 1,10,000 centimeters per minute. So to convert it into centimeters, we are doing it in this way. The centimeters per minute. So 1000 meters you're having. 1 meter is equal to 1000. Then into 100, that is centimeters. Then here R. So you can see here the speed of the car is 66 kilometers per hour. We are converting this into centimeters per minute, and that is equal to, you can convert 1 kilometer is equal to how many centimeters is, you can see here the 1000 into 100 by, and 1 minute means 1 hour is equal to 60 minutes. So by 60 we are doing, so which is equal to so much. Now distance covered by the car in 1 minute is equal to 1,10,000 centimeters. Therefore, distance covered by the car in 10 minutes is equal to 1,10,000 into 10, which is equal to 11 lakh centimeters. So now number of complete revolutions is equal to distance covered in 10 minutes divided by distance covered in 1 revolution. So which is equal to 11 lakh divided by 1760 divided by 7, which is equal to 4375 revolutions. So many complete revolutions it can make in 10 minutes. The wheel makes so many revolutions. So next problem, the fifth one. Tick the correct answer in the following if the perimeter and the area, perimeter is nothing but the circumference, and the area of a circle are numerically equal, then the radius of the circle is A 2 units, B pi units, C 4 units, and D is 7 units. So solution for this, R be the radius of the circle, then perimeter is equal to 2 pi r and area is equal to pi r square. It is given that perimeter of the circle is equal to area of the circle, that is 2 pi r is equal to pi r square. So pi and r are getting cancelled, so therefore it implies that the radius is equal to 2 units. So option is correct. So you can tick here option A. That's the correct answer which you got. That is 2 units.